So last week, Dhruv and I built some baseline models for our Hacker News performance prediction project. And this week, we're going to look at another aspect of standardizing experiments, which is building systems for validating data as it comes in. And we're going to look at a library called Great Expectations, which gives us a way of setting up something that's very much like unit testing, but for data and for checking the qualities of data, its characteristics. It's assessing the distribution of a data set and how it's changing as you continue to take in more and more batches of it. And so when we think about testing on data, what makes unit testing or something like it so difficult with data as compared to other kinds of software projects? A big part of it is that flakiness is a feature. What I mean by that is that we're dealing with an intrinsically non-deterministic system, right? We have information coming in from external sources, and underlying characteristics of the way that information gets generated, that changes over time, sometimes gradually and sometimes suddenly. And so the things that we expect our data to look like today might not match the things that it's going to look like tomorrow. On top of this, pass and fail conditions for tests are not as well defined. We might want to have some sort of test based on the proportion of missing values for a particular, feature in our data. And maybe we're used to seeing, let's say, 1 or 2% of those values are missing. Then if all of a sudden we have a week where 3% are missing, should we say that's a failure because it's outside of our expectations? If there's a week where 0 are missing, is that a failure? And this can be hard to decide ahead of time. And when it comes to setting up tests for data like this, again, it can be helpful to have a good framework to work on top of. And for this, I really do like Great Expectations. And so what is this Great Expectations library? Talk a little bit more about it. It's built for the idea of eliminating pipeline debt, trying to bundle together a whole bunch of really important stuff for testing and documenting data and profiling data as it comes in as well. There's a couple of main ideas we'll look at with Great Expectations as we apply some of this to our dataset and our Hacker News project. And so here's what they are. We'll go over how to specify a data source, how to define expectations, and what expectations are is those are the tests. So an expectation is, I expect that this data set should have this particular column have a mean that's between these values, or I expect that there should be at least this many unique values, or that the maximum should be no bigger than this, or it should be bigger than this, or these kinds of assertions, or again, expectation is really the best word for it, that we can say about a batch of data that comes in. So we have all of these individual questions we're asking of our data, all these expectations. We are going to bundle those together into expectation suites. So that is like a suite of tests. And then the results of those tests are actually going to be generated into some really cool kind of interactive HTML reporting, which Great Expectations calls data docs. That's a lot like what we saw last time around with the HTML reports that we made with the pandas profiler. And so we can think of this as an extension of what we started with profiling our data last week. We started looking at the distributions last week, and now we're setting up a system to continue validating those distributions as more data comes in if we were to keep ingesting more and more of it. So let's get this set up. The first thing that we need to do is define a data source. Actually, that's maybe the second thing that we need to do. The first thing that one does when working with Great Expectations in a particular is actually initializing it, doing what's called creating a context for Great Expectations. That is maybe a fancy word for ultimately a directory that Great Expectations is going to make for us that's going to contain a whole bunch of stuff as we keep working on our expectations. So I'm going to get rid of this and show how we remake that. So hop over into my terminal up here and make sure I'm in the right place. Should be in here. So actually want to go to the project, not root directory, but more like the home directory of the project, where from there we have source, which has all of these scripts that we've been running for training and profiling and such. Our data directories in there, all that good stuff. So that's where we want to initialize. And to initialize, I'm going to say great expectations init. And maybe I will do that, make a little bit more room for that. So I'm going to run this, and it looks like the output is a little bit, let's see, there we go. So here's our initializer screen. So when I do this, basically what happens is Great Expectations is going to create this directory and kind of file structure for us. So this just is going to bundle up everything that we do with Great Expectations is going to live inside this Great Expectations directory. And there's going to be a lot of other directories. There's going to be some YAML, so on and so forth. So we'll go ahead and proceed with that. Now, if you follow along further with the CLI here, it can guide you through doing a lot of what we're going to do in Python scripts, but via the CLI and actually with kind of a very cool and reactive system that opens up Jupyter notebooks for you, which in some cases can be more comfortable for a lot of people to navigate, but I like keeping everything where I can see it, and so we're going to look at setting up Great Expectations just with Python scripts. So we are initialized. That's fantastic. Let's create a data source. And so I have a script here, just calling add data source. I'll go over just some of the big ideas. So the first is that in Great Expectations, which by the way is a Python library, I may have brushed past that, we are typically going to be starting off by saying great expectations.get context. So that will then let the library, or I guess the package, refer to all of that good stuff that Great Expectations set up for us in that directory. So ge.get context. And then as we run other functions and create other objects and such out of that package, they're going to be referring back to the context so that everything knows where to go. So to create a data source, we're going to create a YAML specification. Now, of course, one could do this in an actual YAML file. I'm doing it just in a big multi-line string because this is a pretty straightforward project setup. We don't need a lot of separate configurations, and it just makes it so that I can show everything on screen a little bit more easily, a little bit of a shorter feedback loop. I think that's helpful for stuff of this scale, but you could certainly define this in a separate file. YAML all over the place in Great Expectations, specifying configurations of data sources, of suites, lots of stuff. But when we set up for a data source, I'm going to go over just a few of these things. For one, we want to name our data source. We will continue referring to it by name via the Great Expectations library. And we also need to give the base directory where the data lives. Now for us, that's this data directory right here. And relative to our add data source script, that's up one directory and then data. So I set my default arguments here to just say the default base directory for the data is up one directory and then data. And we're going to say that the name for our data source should be hn_data source, Hacker News data source. Of course, set this up with command line arguments, so I could run it with other arguments, but using these defaults just for convenience now. So we can run this, and we might not see much interesting right now, getting some warnings, but that's all right. So we have our data source. Nothing super exciting has paid off yet. But with that, we can go on to create an expectation suite. So in here, what are we doing? We are going to, really the heart of this one is all of these method calls that we see in this create expectations. So I'm going to be creating this validator, which is a wrapper around a pandas data frame. It's a Great Expectations data frame. And it has all these methods for making not quite assertions, but for defining what we expect that data to look like. And they all have this kind of pretty intuitive, just natural looking API like this. I expect that my data frame has column values to be in this type. So for the score column, they should be integers and floating point values. I expect the column values to not be null. Now I'm saying mostly, so 95% of them should be non-null. If more than that are non-null, if more than 5%, I suppose, are null, then that would fail that expectation. We know that there's going to be some that are null, but we have a little bit of flexibility in defining that mostly argument. I expect the column medium to be between 1 and 3. Now that's something that I picked up actually by looking at the pandas profile that we made last week. And just as an example, we're setting up one expectation that is definitely going to fail, just so that way we can compare how that stuff looks when we go into actually the validation reports. So there's a few other things going on in here, but the big idea is that when you are creating expectation suites, ultimately you're going to get your context. You're going to say create expectation suite. You're going to name, you're going to set up a batch request, which you'll use to, and in there you'll reference dataset. You'll use the batch request to set up a validator. And the validator is what has all of those expectations. So you'll create those expectations, and then finally you'll save the expectation suite with that validator. And at that point, you'll be able to use the expectation suite to test it on your data. So again, we just mentioned the columns we have. We're getting our context, creating the expectation suite, creating a batch request, which lets us get, in this case, just like 1,000 rows out of train.pickle. We have our validator. We're going to validate it to make sure everything looks okay. We're going to create the expectations, and then we're going to save that suite. So let's run this script. I will say as well that I actually don't have all of the command line argument stuff set up in this script just yet. As I keep working on this, I'm going to be doing more of that and making sure that this is more robust to if we wanted to reference other artifacts and stuff like that. But this is the bones of it, so to speak. And so finally, we can actually do some validation and we can see what our results look like. So a little bit more room. There's a little bit more going on in this one. So once again, we're defining the columns that are in our data set. We are importing some stuff for fetching data from Comet artifacts. We are going to be creating Comet experiments in this one. And for our command line arguments, we're asking for the artifact name and version, just like we did when we were profiling and training last week. We're going to be asking for the data split. For us, currently, that's just train and validate. We're going to be referencing an expectation suite by name. Now, last time we named our expectation suite hnsuite.demo. We want to set a validation threshold, more on that in a second. And we want to set a message to log to Comet just so that we can keep our runs organized in the Comet UI. And then I have this create validation batch report function. Create validation report function. This is going to validate, and then it's going to actually render out HTML that we can log to Comet and view in a nice interactive way. So what do? We create our context. We're going to initialize a Comet experiment. We're going to fetch our artifact. We're going to get the data path. So if we wanted to check the validation data set, I think for us that's valid, I think is the name of that split in the artifact metadata. We are going to, just like last time, create a batch request, create a validator, create expectations, save the expectation suite. And then we are going to, going to log not just the results of validating our expectations, but also going to log the JSON specification of the expectation suite so that we can reference that later too. That way, in case our testing structure changes as we go along, when we're referencing old runs, we can make sure we know not only what the results are, but what the questions were that we were asking. So we'll create our validation report. We'll log a couple of things to Comet, including the HTML. And then we're also going to tag this run with whether it failed or succeeded based on our threshold. So we had a default threshold of 75, meaning that at least 75% of our expectations need to pass for us to consider it a success. If fewer than 75% of them pass, then we would say the experiment failed. Now again, we are trying to cope with uncertainty here. We know that there's going to be some flakiness intrinsic in the process of testing data. We have some flexibility to set that threshold as appropriate depending on the problem in the project. I will say too that the expectation suites that we've been looking at so far, where I'm just doing a couple of these little things here. These are pretty rudimentary. As we keep building out this project, we're going to be making more robust expectation suites that are especially that are going to be more and more relevant as we start incorporating data features and building more powerful models. But this is just supposed to be an illustrative example. In any case, why don't we open up that Comet experiment so we can see that some of our metrics logged. So we know that we evaluated 4 expectations in this case. 75% of those succeeded. Now, we expected one of them to fail, of course, because we set one that said that the average score should be between 1 and 2. It's just not the case. But why don't we actually get the nice representation of all of this stuff? So if I look at the HTML that I logged for this experiment, we can see what Great Expectations data docs look like. They look like this. And so we have some nice basic interactivity here. So we know that we evaluated 4 expectations. 3 of them were successful, 1 was unsuccessful. We can get further detail on the versions of things we're running. When something ran, we have a way of hashing our pandas data, which is pretty cool. We can also look at the score. So it seems in this case that the reason that we failed one expectation is that the actual mean score was about 14.86, and we were asking it to be between 1 and 2, which is simply unrealistic. Now, as we have more and more expectations and more complicated data models, we might have so many of them that it's difficult to navigate all of these or can't look at them all at the same time. And so Great Expectations builds in this search, which is super cool. And so I can pull up, and I guess that one's not gonna work, but I guess if I go by something so we can actually search this table and filter rows based on what we're interested in. And we can append that to, any Comet project, or I suppose any Comet experiment run. So that has been the intro to using Great Expectations. Again, as we continue to build on this work, and as we continue to build new models, we can revisit our expectations. We can revisit these suites of expectations that we have been defining, and we can actually incorporate more and more rules that dictate what we expect the behavior of our data to be. All right, thanks everybody.